Okay, guys, so we are going to be covering everything on research, which is right over here. And then we're going to move over here and talk about intelligence. When we talk about intelligence, and you see the green in there, we're going to move over to talking about different types of testing as well, mixed in with the research. And as you can see, there's going to be the lovely normal curve. So what we're going to do is we're going to focus on research first. Okay, so this is just the research graphic. You can combine them all together or separately, however best works for you. But when we talk about research, research goes along with the scientific method. You need to know all the steps of the scientific method. Here, I just posted the majority of them. Definitely know operational definition. Operational definition is where we define everything that we're testing in the research. So, for example, if you're testing love relationships, you need to operationally define what love means, whether it's in family relationships, friend relationships, or significant others, or all of the above. Then, once you decide how you're going to test, that's what moves us over to the research methods. So, you have to decide what type of method you're going to do in your test, which we're going to talk about in a second. Once you calculate all the results, once you do everything related to the method, then you're going to have the results all together. Those results are going to come in a combination of many different ways. Usually gives numbers like the correlational coefficient, which is right up here, that graph, or it's going to go in the sense of how reliable or valid the scores are. We're going to look at a normal curve, things like that. All of that gives us different ideas for testing results, or for research results, excuse me. But we don't really calculate results in here, so you just need to know the rough idea of results mean. Results are definitely going to have the concept of measures of central tendency, mean, median, and mode. Those are easy. You can get those on your own. And then measures of variation. Measures of variation, definitely that normal curve, okay? So the normal curve is looking at the measures of variation. Again, we're going to explain that in more detail here in a little bit. Okay, so then you can create a theory potentially, and then the whole goal is to produce the research that you've done so you or anyone else can replicate it in a similar way so we can actually figure out about human psychological phenomenon, okay? But let's focus on that research method part. Over here are your 7 research methods right here, and also this chart, which you can zoom in on later. Sorry, it's kind of awkward walking around here. This chart here gives you a little bit more information about the purpose, strengths, and weaknesses related to it. You guys saw this in the study groups when Miss Perry was here, okay? All right, so these are the 7 different methods: case study, individual study of one person or a few people to learn a little bit more about them and whatever disorder they're suffering from or situation they have. Inside a case study, we are able to get a lot of in-depth information about that one person. However, that one person does not necessarily relate to the entire population of people. So a case study would not be the only thing we use to learn about that disorder or situation the person's going through. We would definitely have to make sure to use another study, which again, this chart is going to explore a little bit more in the sense of strengths and weaknesses, okay? And a correlate, actually, we're going to skip correlation for right this second. We're going to do the easy ones right now, and then I'll move over to correlation. So in a cross-sectional study, that's when we want to get a study across different ages. So we're going to make sure we get a group of 5-year-olds, 10-year-olds, 15-year-olds, and we're going to study them separately to figure out how they deal with certain things, like maybe the sense of like TV violence and their violent behavior. So we can see what a 5-year-old's likely to do, a 10-year-old, 15-year-old. That saves us time, so we don't have to do a longitudinal study. So cross-sectional would be we can study everyone right here, right now. Whereas in a longitudinal study, we're going to study the same person all the way for 10 years. So when they're 5, 10, and 15, that same person will get information on, hence longitudinal. And so we can see how does that person legitimately progress, not just what they look like when they're 5. Okay. Now with the longitudinal, it's incredibly time consuming, very expensive. Again, your chart will help you. You can see that longitudinal studies, unfortunately, is not on this chart. So just know the strengths are, we can get a lot of information about how people change over time. Definitely great for development. Weaknesses are really expensive, very time consuming, and sometimes they go so long that people drop out of the study. The participants do, and then also researchers may have trouble finishing up due to the length of time. Okay. Then we also have a naturalistic observation, and that's where you're observing someone in their natural environment. What are they normally doing? Again, remember, observer bias is a problem. You can't you have to make sure that the people don't know you're watching them. And they don't change the behaviors. If they find out you're watching them, they're definitely going to change, and that could be a problem. Also, we want to make sure we don't have any bias ourselves when we observe somebody, so we can't have any preconceived notions. We're simply just seeing their actual behavior. So over here on this chart gives you a little bit about strengths and weaknesses on naturalistic observation. Naturalistic observation goes along the idea of nature versus nurture. Naturalistic observation, we're exploring someone in their own environment, which emphasizes the nurture side of the debate, meaning that our environment is what dictates our behaviors, not our genetics. Nature would be genetics, okay? Then we also have surveys. Surveys use a random sample. They randomly find people to be in their study. They're going to randomly pick 100 people, okay, or 500 or whatever. In a survey, incredibly cost effective. It's cheap, not time consuming. Able to get lots and lots of information because we're studying a huge group as opposed to just a few people. Again, survey will help you here in this pro and con chart. Cons are the way we word the questions can be an issue. Not everyone responds correctly, nor does everyone actually respond or complete the survey. Okay. Okay, so I went over those pretty quickly. If you have questions, just let me know any other time. What now we're going to do is we're going to look at correlational studies versus experimentation. And this is going to bring us over here. So we're going to look at correlation first. Okay. So in correlational studies, we cannot prove cause and effect, hence the no causation. No causation, cannot prove cause and effect. Cause and effect is proved in an experiment. So in correlational studies, we only show whether there's an actual relationship that exists between the two factors. So whether one affects the other. When we're doing a correlational study, this brings down to results. You can see here the results can be shown on a scatter plot. Okay, the scatter plot, when we get results, a positive is going to go in this direction. A negative correlation goes in that direction. Okay, so positive correlation up this way, negative this way. No correlation, dots all over the place. So our results will look like this in a scatter plot, sometimes shown on multiple choice questions. When we're looking at whether it's a positive or a negative correlation, that kind of goes over here to the correlation coefficient number. You can see here that over here we have a -1 all the way to a +1. These are the numbers on a correlation coefficient. Never do you have numbers outside of -1, outside of +1. 0 indicating no relationship exists. Very weak relationship. -0.5, +0.5. Anything that increases above that indicates a significant relationship between two factors. Okay. So again, this could also be seen on multiple choice questions. Bringing back to positive versus negative correlations. A negative correlation is an inverse relationship producing a negative number. It is not negative because the relationship is bad. It is negative because the two factors go in opposite directions. For example, the hotter it is outside, right? The hotter it is outside, the less clothing people wear. One's moving up while the other is going down. And a positive correlation, it simply means that two factors are rising or increasing together. So the hotter it is outside, the more your air conditioning runs, okay? So both increase at the same time, All right, so that's what's the difference between positive versus negative. Negative is also called an inverse relationship. Okay. All right, so sometimes when we're looking at correlations, two factors and how they compare to each other, we can get what's called an illusory correlation, where it looks as if there's a relationship, but technically the two things don't have factors with each other. I'm trying to think of a good example for that. For example, the other day we talked about how that woman was sucked out of the airplane. I know, rough. She was sucked out of the airplane. So at this point now, maybe a lot of people are thinking, oh my gosh, I've heard a lot of plane issues, a lot of plane failures. So ladies getting sucked out of airplanes. Now I think that there's a relationship with flying planes is a really unsafe form of travel. We all know that's not the case. The most unsafe form of travel is driving in a vehicle. So it looks as if there's a correlation, but technically there is not. It's just something that we're paying attention to right now. Hence, it's also called an availability heuristic, what's available to you currently. So it's presenting it as an illusory correlation, though it's not. Okay? So that is the information on correlations. Again, I'm not proving causation, only showing a relationship exists. Okay? Now, if I want to show a relationship exists, that's when I move over here to an experiment. So again, we're still on the research topic, okay? So when I want to show that there's a relationship exists, I'm going to perform an experiment. Again, it proves causation, okay? Now, lots of things happening up here. So let's say we're setting up that experiment where someone's getting a new drug. They get a new drug because they have schizophrenia and we're trying to reduce symptoms, okay? So I know that I'm going to test a new drug. The new drug is the independent variable, what I manipulate, what the researcher is manipulating, changing to see if it changes things within human population, human nature. The dependent variable is going to change based on that independent variable. So independent variable being the new drug, dependent variable is going to be whether your symptoms reduce or not. Okay. Now that we know what we're testing, which is going to go along with that scientific method, the hypothesis, operational definitions, defining what kind of drug we're giving. We've already decided a research method because we're doing an experiment. So then we have to actually put the experiment together, calculate it. So let's talk about how we put the experiment together. So when we put an experiment together, first and foremost, we need participants, okay? So we need to find a whole bunch of schizophrenics, okay? We're going to get a random selection there. We're going to randomly select them to be the experiment. Random sample over here in survey simply means we're just randomly gathering a whole lot of people. Random selection indicates that we have some selection process, like they have to be schizophrenic. And a survey just has to be anyone between particular ages or whatever the case may be. So I'm randomly going to select people to be in my experiment. Obviously the random is important. We want to eliminate any type of bias, which is, where did that go? We have bias issue. Oh yeah, it's right over here. So we want to eliminate any type of research bias. We'll come back to this as experimenter bias. So we want to make sure that it's all at random. We don't select them, okay? Once we get, let's say, 100 schizophrenics randomly selected to be in my experiment, I have to decide what group they're going to go into, okay? And that's through the use of random assignment. These 100 people will now be randomly assigned to one of the two groups, control or experimental group, which means that I'm going to pluck their names out of a hat or let the computer roll the dice and put 50 in one group, 50 in the other. When I put 50 in the control group or 50 in the experimental group, these groups have significant things to do with the research, okay? The experimental group is going to receive my independent variable, therefore they're going to receive the new drug. I want to see, are their symptoms going to reduce taking this medication? Okay, if so, then I'm satisfying my hypothesis over here, potentially getting significant testing results, okay? Now, when I'm looking at experimental group, again, receiving the independent variable, okay? My other 50 are in the control group. The control group is a comparison group. They are not going to receive the independent variable. They are going to be comparing to the people that have the independent variable. So they have no medication. Let's see their normal symptoms acting as if they've never been medicated before. So in certain cases, when participants believe that they're not getting a medication or treatment, they think they can't actually get better, which can potentially make issues within the experiment, which is called participant bias. So we want to eliminate, again, lower participant bias. So in my control group, I'm going to actually give my control group what's called a placebo, okay? A placebo is a sugar pill, an inactive substance that does nothing. However, they don't know it's a placebo. So now both control and experimental group are ingesting a product, okay? Now, what might happen is the control group thinks that they're getting medication. First of all, they don't even know they're a control group because that you can't let them know what's happening there. We don't want their information, their opinions, what they think should happen get in the way. Which they can sometimes report that they're getting better for no good reason. They should not be. And this is something called the placebo effect. And that is where they're taking a drug. Well, they think it's a drug, but it's really nothing. And they think they should be getting better. So therefore, they report signs of being better. But it's mind over matter, not a legitimate thing. Okay? So again, that eliminates participant bias issues. Now, we're eliminating participant bias, but we still potentially have experimental bias. We still try to eliminate that experimental bias with random selection and random assignment, but we also can do other things while the research is being conducted, like looking at a single versus double blind study. Single blind study reduces participant bias because they're blind to who's receiving the treatment, hence the reason why we may give a placebo. They don't realize there's an experimental group receiving the drug, okay? Now, in a double-blind study, I'm going to reduce not only participant bias, but I'm also going to reduce researcher or experimenter bias, okay? Because then they are unaware of who is in the experimental or control group, so they cannot encourage you to respond appropriately. Like they can't go to the experimental group, hey, you should totally be feeling better today. That's not a possibility because they don't even know if they're in the experimental group. Therefore, they do not want to ultimately encourage behavior that's not appropriate for the study. So they actually remain objective, or at least we hope so. Okay? Okay, so again, in an experimentation, we prove causation. We conduct the experiment with the use of an independent, dependent variable. Okay? Participants are going to be a part of the independent variable potentially if they are placed in the experimental group. I want to make sure that my participants and my researcher do not change the results. We really want to see what's happening. We're trying to make sure that psychology remains a very effective hard science, hence the reason why we're making sure everything is done in research, okay? So that is all the major ploys to research, with the exception of limitations we're going to talk about in a second, and the exception of some of our results, reliability, validity, which we're going to talk about a little bit more in testing. It'll make more sense there. Okay, so for limitations, again, we're eliminating experimenter bias, okay? Also, overconfidence can happen with a participant or with the researcher. They're overconfident that their experiment is designed effectively and they think everything's going to go the way that they have planned. Again, humans, you never know. We're all, kind of off the cuff, okay? Sometimes hindsight bias changes things. Like, we now realize what's happening in their experiment or with human behavior, something we didn't notice beforehand, and now we're like, duh, obviously we should have known that. And again, that's hindsight. Hindsight's 20/20. Now that we've seen it, we totally get it. Beforehand, we didn't even think about it as a possibility. Okay, so let's move over here now that we're done with research. Oh, and here, this is a big chart that also was in your groups. This kind of puts everything down on history and research a little bit. You can zoom in on that potentially. So this is a little bit more in history, ethics, which is definitely related to research. Again, that's really easy. Make sure you just maintain ethics. So it's just set up there. Here's everything that we've kind of been talking about. Okay, here's how we measure data, which we're going to get into more when we talk about testing in a second. We got that mean, median, mode, correlation, scatter plot. Okay, we're going to talk about variation here in a little bit. And then up here is how we conduct an actual experiment. We just talked all about that. Okay. Oh, we did not mention confounding variables. Confounding variables, again, go into experiments right over here. Confounding variables are a variable you did not account for, but it acts as if it is the independent variable. So you can have multiple independent variables in your research, okay? So let's move over here to talk about intelligence, okay? When we talk about intelligence, very, very important to know all the theories of intelligence. This chart here is slightly confusing, but it's a combination of intelligence, people, significant people, things like that might help you. When we talk about our theories of intelligence, there are 4 of them, well, 5 of them really, okay? So the very first theory of intelligence is Charles Spearman with his G factor. We have one overall intelligence or general factor, how smart we are basically for the most part, or really how much can we process. And the S factor is the significant abilities we have. So we're always going to have a general level of intelligence. Most of us are going to be average, some above average. However, or below, depending upon the case. However, even though we have that level of intelligence, there are some areas we might be incredibly intelligent in, very, very high intelligence in one particular area, and that is the S factor, okay? Now, Thurstone disagreed. He said, you know what, we can't just study one factor. That's not really going to help anybody. And so, being that this was the first perspective, we've advanced a little bit. So L.O. Thurstone said, no, we need to look at a multiple intelligence, okay? Now, Thurstone put out 7 different types of intelligences. Are they on this chart? I don't think so. But yeah. Okay, so Thurstone talked about primary mental abilities, and that is within multiple intelligence. Again, still academic and focus. So those are everything that's like mathematical, verbal, English language, all processing skills, academic focus. So what ended up happening was we still got a primary score, the G factor. We didn't really kind of branch out. We just broke down all the factors that we need to study in a test. So Howard Gardner said, okay, let's look at this. What really is multiple intelligence, okay? Multiple intelligence is beyond academic. It also includes non-academic components like kinesthetic, musical talent, naturalistic, intra and interpersonal ability, okay? All of those non-academic components are just as important as the academic. So Howard Gardner said that there are originally 8 academic components. No, there were originally 7, and then he added the 8th and 9th and 10th, okay? 8th being naturalistic, okay? 9 and 10 we don't really need to go into. You just need to know 8 was naturalistic, all right? He backed all of this research up, all the idea that we have in multiple intelligence, but they go to non-academic components as well as academic components. He backed this research up with savant syndrome. People with savant syndrome have an incredible talent in one area, but they actually have an incredibly low intellectual score. So their intelligence score would be low, but their capability in one particular area would be extremely to the top, most gifted, advanced. He recognized that academic abilities are not the only thing to assess. We can look at the non-academic. Sternberg also looked at multiple intelligences, but he said that we need to break them down into 3 different chunks or categories. The creative ability is your ability to think outside the box, manipulate different tools that you're getting, really being able to just kind of adapt to the environment around you, and not be so stringent. Analytical, academic components, all the way. Practical is your ability to socialize with other people, ability to adapt to a new environment, ability for change, all those fun things. Okay. Now, Goldman, he recognized emotional intelligence. So it's not an IQ, it is actually an EQ, emotional intelligence, okay? That's where we're looking at whether the person is able to recognize their own emotions, recognize other people's emotions, and harness and manage them appropriately, okay? Okay, so that was pretty quick on those theories. If you have any more questions on them, please come talk to me. I'm more than happy to help you or reference your notes and things of that nature. Okay, so these are all the theories of intelligence. Let's talk about when we actually start testing on intelligence. So the first person to create an intelligence test is Alfred Binet. Alfred Binet created the Binet intelligence test. If you remember, the French government or Parisian government asked him to do so, which he wasn't too happy about, due to the fact that he knew that people would use the results to quantify how smart people are, which it really isn't effective. But that happened anyway, so poor Alfred Binet died knowing that things happened the way they weren't supposed to, but he did create the first intelligence test that was translated to many different countries, including the United States. But the United States did not adapt well to that change in language. So what we did was we had to create a new test that actually assessed what people in the United States would know. Because remember, intelligence tests are considered to be culturally biased, meaning that we ask questions that you in that culture, you in that time frame would understand, not anybody else. So we have to see how practical intelligent we are as well as academically and various other components. So Lewis Terman revised the Binet to become the Stanford Binet Intelligence Test. He worked for Stanford University. Binet is a homage to the original test creator. Now, Lewis Terman and William Stern worked together to create the first intelligence quotient. So this is the first way we can get a numerical format for the actual number you have. That's where we look at the mental age divided by your chronological age times 100 equals your intelligence. 100 is multiplied here because that is the average score. The majority of the population score 100. Now, the score of 100 is actually technically on a range. It's a range between 90 to 109, 100 being set in the middle. We'll talk about that a little bit further. Now, the test that we currently use today is not the Stanford Binet. It is the Wechsler Intelligence Test. So David Wechsler created the most advanced test that we're using nowadays. It's either the WAIS or the WISC that's provided. The WISC is what you guys would have taken in elementary school. It's for the Wechsler Intelligence Scale for children. Whereas the WAIS is what adults would take in situations of many different things like health issues, like maybe someone got in an accident trying now to get disabilities, or we're looking at continuing disabilities for different people that went from childhood to adulthood having problems. The WAIS is the Wechsler Adult Intelligence Scale. Okay, the WISC is obviously most given, and it's usually given first to assess giftedness and then various other components. Okay, the Wechsler test has both a performance, that paper's in the way, but has both a performance and a verbal scale. Okay, so performance, you have to put puzzles together. Here's what the puzzle looks like. Here's all the puzzle pieces, pop them together. Verbal, tell me what you see on the paper, read this passage, things of that nature. Okay, when we are giving an intelligence test, the intellectual scale matters. This is where we use that formula, MA divided by CA times 100, to get your intelligence score. This gives you the ranges of gifted, which starts at 130, important to know, 100 being average, okay? Now, that is the average to above average to highly gifted. This is intellectual disability, okay? When we start at the moderate intellectual, no, actually, my bad. When we start at the mild, that is where government is actually going to start classifying different types of intelligence. Again, government classifies intellectual disability at the mild range. Borderline, which is not on here, okay? Borderline is 70 to 79. That is not classified, okay? Which means they would not receive Social Security financial help from the government, okay? All right, so those are the scores we're gonna get, but how do I know my score is truly gifted? What do I know to do that? And that's what's gonna bring us to the normal curve, okay? Remember over here when I talked about measures of variation, the whole goal is in this normal curve, the whole goal is to see what do my scores look like compared to everybody else. So how does my score vary away from the average? So down here, you see standard deviation and mean. All of that's looking at how much does the score vary away from the mean. So let's say that you have a score of 130. No, let's do 115, okay? If you have a score of 115, how many people actually score that? Am I a little bit super special? Am I just about where I'm supposed to be? Like, what am I looking at? Okay. And so that's what the rest of this chart is going to do. It's going to be looking at the percentage, knowing exactly what you do that's effective. Okay. So let's break this all down. Okay. All right. So first of all, the mean down here, the mean right there, is always 100, okay? So average population score is 100, alrighty? So that's 50%. Standard deviation, SD, standard deviation, means that we are deviating, moving away from. So how much do we move away from the mean in this direction? How much do we move away from the mean in that direction? That variation is what the significant piece is to tell you what your score means to everybody else's score, okay? And that's how we're going to understand the population. So I always tell you, it's one standard deviation above and below the mean, okay? This is above the mean, this is below. This combination is 68% of the whole population that can score within this range. So the majority of the population scores here. Well, like a little over half. Almost everyone's going to score within 2 standard deviations above and below the mean. Just as an FYI, this here is going to kind of get closer to starting intellectual disability. This gets over here to gifted, okay? So we have intellectual disability up to gifted. That huge chunk, 95% of the whole population scores here. Here's how I find that number. I always tell you when you go into testing, remember 3 numbers. 68%, 95%, 100 is the mean. Always remember those 3 numbers. The rest you can break down. So if I were to ask you what percentage of the population scores within 1 standard deviation above and below the mean, okay, that's 34% of the whole population. Here's how I know that. 68 divided in half is 34. So 34% is going to be here in this 1 standard deviation below the mean. 34% is 1 standard deviation above the mean, making a combination of 68% total. Okay. Now, if I wanted to know how much of the population is going to score here right before we get to gifted, okay, the reason why I know that's 13% is because I know this. 95%, well, how about this? Well, if I know 95%, I just subtract 68 from 95. Okay, 95 minus 68 gives me roughly 28. Okay, divide that in half. We have each side here, which is, I said roughly because the number's a little off. We have about 14%, or 13.5 here, 13.5 here. Okay, so that's going to give us the separate individual population there. Okay, memorizing all these numbers would take you forever. 68, 95, 100 is going to help you break this down. Now, the other thing to know, okay, what is standard deviation? Like, I don't see any test score numbers down here. I know this is 100, but what is this? Okay, each standard deviation is about 10 to 15 points away from the mean. Okay, so this means 100. Most standard deviation is about 15 points. So this is 115, 130, 145. This is 85. This is 70, etc. Oh, whoops, sorry. This is 100, so 115 minus 100 is 85, okay? And this is going to be 70 on the way down. It's about 15 points in standard deviation, okay? Now, if you come to a test and they tell you the mean is not 100, they say the mean is 20, standard deviation is 5. You write 20 here, and then each standard deviation point, it goes up 5, okay? So 20, 25, 30, 35, because it said standard deviation is 5. So 20 is here, and then this would be 15, this would be 10, etc., because standard deviation is 5 points away from the mean, okay? So this is a little bit more about what I was just describing, okay? If you have questions on that, please come see me. I'm more than happy to help you. So standard deviation gives us our variation away from the mean. The other thing that we need to talk about is reliability and validity. So is the test reliable? Meaning, does it have consistency? Is the test Valid means it measures what it's supposed to measure. Here's my bell to tell me I need to stop, but I'm going to go real quick. So if I'm looking at reliability, I need to know the difference between test, retest, split half, and inter-rater. Okay. If I'm looking at validity, I need to know, does it actually measure what I'm intending to measure? Is the content solid? Is it actually studying AP Psych, or is it looking at science? Is it predictive? Will I know that this person truly knows the topic? And then criterion, okay? So those are the major components there of research. Make sure you look at that. This chart here is going to help you a little bit further understanding those components, okay? All right, guys, I got to get to class. Hopefully this helped you.